such as deforming force, elasticity, strain and stress, Hooke's law, Young's modulus of elasticity. Today I am going to start a topic that is about modulus of elasticity. Now, modulus of elasticity means, this topic, modulus of elasticity means the ratio of stress and strain. Now, as I have already told you, stress is the force which a body applies when a body can, the force which is applied to change the shape of the body, and strain is the change that is occurred in the body. So, ratio of that is known as modulus of rigidity. Sorry, modulus of elasticity. Now, this topic is very modulus of rigidity. It is modulus of elasticity. Now, what modulus of elasticity means? Suppose we have a body of a definite shape. Suppose a box of definite shape. If you apply pressure to all the surface, the equal pressure on all the sides of the box, then what happens is the volume of this box will change, but the shape remains the same. So over here, what happens is the size will change. So it becomes quite smaller than this was there. The size will change. The shape will change. Sorry, the shape remains the same. Size will change. Over here, what has changed is volume changes, shape remains the same. So, in the bulk modulus of rigidity or elasticity, what happens is volume changes, but the shape of the object remains the same, and we are applying equal pressure on all the sides. That is why the shape is still remaining the same, the volume is changing. So, over here, what type of strain and stress is applied? First, there is a change in shape. There is a change in volume. So, it is a type of a volume strain. So, there is strain in volume, so it will be volume strain. Now, suppose the initial volume of this is V. Change in the volume is del V. Now, volume strain will be change in the volume divided by the actual volume. Now, it will be minus because the volume has decreased. If it had been increased, it would have been plus. It is decreasing, so it will be minus. Volume strain. Now, stress. What type of stress is applied to the object? The stress is applied in a perpendicular direction. Suppose if this is an object, the stress is applied in a perpendicular direction to the faces of the object. So it is normal. Normal doesn't mean normal situation. It means normal in language of mathematics. It means perpendicular stress. So perpendicular stress is actually the pressure which has been applied to each face. So bulk modulus of rigidity. Okay, let's have rigidity by elasticity. Bulk modulus of elasticity denoted by V is normal stress divided by volume strain. So now, normal stress is G, volume strain is del V divided by V, which is P divided by del V. Okay, minus PV divided by del V. So this is your bulk modulus of elasticity. Now, with that, we come to another topic, that is modulus of rigidity. Now, over here in the modulus of rigidity, we take the same type of an object Now in this object, suppose the face of this is AB, only the first face of the box. I'm taking only the first face of the box. Now suppose I apply a tangential force on this. Tangential force will only at the top surface. Suppose if I apply force only to the top surface, not to the bottom surface, then what happens if the bottom surface is fixed, only the upper surface is free. If I apply a force at the top surface, then what happens is the volume of this body remains the same. The volume, the size remains the same. So over here what happens is volume remains the same. What changes is the shape of the object will change. So how does the shape change? Now if this is an object, if you apply a tangential force, then its shape will change only at the top surface. So the shape of this object will be now the shape of the first face will be like this. It will move this way. Just look at the first surface. It looks quite confusing. You can refer to the diagram below also. Just look at the first surface. Okay, the first face. If you look at the first face, what is happening over here is only the upward surface is moving that side. Suppose this is A dash, this is B dash. I'll draw another diagram for this. Suppose if you apply a tangential force at the top surface, then the shape will become okay, the first face will move like this. Okay, this is BC, this is B dash, this is A dash. Okay, this is the first face of this box. Now over here, what you have to find is, since the body is sheared, okay, it is sheared, so the change over here will be shearing stress and shearing strain. So what you have to find is, you have to find shearing stress and shearing strain. Okay, you have to find shearing stress and shearing strain. Now, for shearing stress, stress is force applied for which area. So it is force for which area. This will do. Okay. Now, for the shearing strain, the strain part, strain is the amount of change in the body. So what will be the amount of change? If this angle over here, the change of the body is in terms of angle theta, so the shearing strain will be your theta. So what is theta? From this particular triangle over here, okay, the theta will be, this point is B dash, B dash divided by BC. So it will be B dash divided by BC. This is the amount of theta. Okay, just for knowledge, so B dash divided by BC is the change in the amount divided by the side which is unchanged. Or theta is, you can write down, displacement of the upper surface divided by, okay, displacement of the upper surface. This is the displacement of the upper surface divided by displacement of the upper surface from the fixed point. That is this displacement of upper surface from the fixed point. This is the fixed point, so amount of displacement this side divided by this side is the amount of change that is shearing strain. So modulus of rigidity. denoted by nu. Okay, this is not n, this is nu. Will be shearing stress F divided by A divided by shearing strain, that is theta. Okay, or this can be written as F divided by A theta, because this is modulus of rigidity, and unit is still the same, that is Newton per meter square. Now the last topic which I am going to do for today is Poisson's ratio. It's one of the most important topics from this chapter. That is Poisson's ratio. Name of the scientist Poisson. Now, in the Poisson's ratio, we take a body, a cylindrical object. Okay, now we take a cylindrical object and we put a tangential stress over it. Okay, we hand an object or we try to increase the length of this one. So what happens? Initially, the length of this object is L. Diameter is D. Now, when we apply some force, tensile stress, okay, it's actually known as tensile stress, it contracts the perpendicular distance. Now, what happens when you apply a tensile force? That means we try to increase the length of the object will increase. Rather, the diameter of the object will decrease. Okay, the object will shrink, but the length will increase. So this object will become somewhat like this. That means the length has changed. It is L plus del L. Del L amount of the length has increased, whereas the diameter, which was D, diameter will be minus D. There will be a change in the diameter. Rather, the diameter will decrease, the length will increase. So this is what happens when you apply a tensile stress. Now the ratio of strain. Okay, the ratio of strain, that is the ratio of longitudinal strain to the lateral strain. Okay, the ratio of longitudinal strain and lateral strain is the Poisson's ratio denoted by rho. Okay, denoted by rho. Now, let us find the lateral strain first. Lateral strain means the change of diameter in the lateral side. So, lateral strain is will be the change in the diameter divided by the actual diameter. Change in diameter divided by the actual diameter. Second is longitudinal strain, that is change in the length by actual length. So now the ratio of this is the Poisson's ratio. It is lateral strain, that is lateral strain del D divided by D for longitudinal strain del L divided by L. Now we can rearrange this. It is in terms of diameter. So this can be written as rho is equal to del T into L divided by L del L into D. Okay, del D into L divided by del L into D. Now, if R is the radius of the wire of the cylindrical body, okay, R is the radius of the cylindrical body or the wire, then what happens to D? D is equal to twice R. Okay, the diameter is twice the radius, so we can change it over here. Rho is equal to, in place of del T, I am writing twice del R into L divided by del L remains as it is. In place of G, it is twice R. cancel. So this becomes del R L divided by del L R. This is the Poisson's ratio. Now, as it is a ratio will be unitless, so Poisson's ratio doesn't have any units. Okay. For most of the solid material, the value of rho or Poisson's ratio is less than 0.5. It lies between 0.25 and 0.35. So every object has their own Poisson's ratio because it is a constant factor. It depends upon the different types of material. So this is what we have studied till now. We'll continue in the next class with another topic, and I'll just check the syllabus. If this chapter is over, I'll start a new chapter. Okay? This much for today. Thank you very much.